We're going to be talking about the graph of a function, and with a single valued function we can associate it with a graph in the xy plane. First off, I'm going to let's draw a picture. So we're just going to kind of sketch out the xy plane here. Okay, so I pick a point on the x-axis. We'll just call it x of 1. How's that? And I'm going to pick a point over here on the y-axis, and we'll call that y sub 1. Now, if we're graphing our function, and we have some ordered pair, x of 1, y sub 1, where does it go on our graph? X is the directed distance from the y-axis. So x of 1 is considered to be the directed distance from the y-axis. And y sub 1 is the directed distance from the x-axis, or f of x, let's say, is the directed distance from the x-axis. And there we are, right there. So this point right here is x of 1, y sub 1. Let's look at an example. So this time we're going to actually define what our function is. Let's call our function h of x and the square root of x. So h of x is equal to the square root of x. So we've defined our function. And I want to graph this function. And so what we're going to do, can I plug a negative number in? Is there a point over here on the x-axis, right, that's associated with a point coming from the y-axis? And that is no, because underneath the radical you can't plug any negative numbers in. But we can plug 0 in. So h of 0 and the square root of 0 is 0. So that is a point on our graph. Now what about h of 1? Right, the square root of 1 is 1. So we'll say this is 1 here, and we get 1 out. 2, the square root of 2. I don't know, the square root of 2 is like 1.41. We'll say that it's about right here. Plugging 2 in, or 3, let's plug 3 in. Right, h of 3. And of course you'd end up getting the square root of 3. If I wanted to kind of sketch this graph out, we would be looking at something that's doing something like this. Right, now my point was supposed to pass through there. And by observing our picture, we can make many useful observations that we'll be discussing in calculus. So just by looking at this and having an idea of what the graph looks like can really save you a lot of time. I want to go back to a picture that we talked about earlier when we were talking about equations. And that was the equation to a circle. So let's say that we happen to have a circle in the plane somewhere. And remember, if you can remember, what the equation to a circle is, so this is the center, and we usually called the center H and K, and it had some radius R. And so just to kind of refresh your memory, our equation went like this: x minus h squared plus y minus k squared. And so if we knew what the radius was and we knew what its center was, we would basically have the equation to this circle. And if you took any point and plugged it in, so this was some point right here, x and y, and if you plug that point in, this left hand side should equal what the radius squared is. Isn't that amazing? That's fascinating, I think. No matter what point you pick, there's infinitely many of them if you plugged it in. Right, the left hand side should equal the right hand side. Well, this was an equation to a circle, but we're talking about graphing functions here. And one way to be able to look at a graph and tell whether it's a function or not is by what's called the vertical line test. The vertical line test. And that means that if I took a vertical line, okay, I'm going to try to make a vertical line, and ran it through our graph, if it passes through more than one point on the graph, then this is not a function. So what you're going to need to do is, if you want to describe this circle as a function, you're going to need to solve for, let's say, y in this particular problem. And what we're going to end up getting is we're going to end up getting two separate functions, and one is going to represent the top of this curve, and the other one would represent the bottom of the curve. So that's kind of the connection there between the equation of a circle and if we were wanting to look at it more as a function and how we would have to break that up. Now there are some special graphs that you need to remember, and if you just memorize these functions, it is going to save you a tremendous amount of time. Now some of the basic graphs that you need to know, and we're just going to quickly sketch these out. And that is f of x is equal to x, and that's going to be just a straight line. So you need to know what a straight line and what that function looks like. Another one is, I think I'll just go ahead and draw it on this same graph, is this guy. And this is supposed to be, we'll call this h of x. This is a parabola. So when you see x squared, you need to think of a parabola. Right? X squared, think of a parabola. We'll call this one s of x, and this is going to be x cubed. So if I see x cubed, right, this green part, this green line here, this green curve, right, this represents x cubed. So this is the graph of x cubed. I think I'm going to draw another one here. That was getting kind of crowded. It was getting crowded in the club there. All right, what about, let's see, another special one is the absolute value function. We'll just go back to f of x. Right, so if we graphed, right, f of x is equal to x, remember we get this, but if we take its absolute value now, let me just continue this line on. But remember, taking the absolute value turns the negative numbers into their positives, right? So that graph is getting reflected about the x-axis over here on the negative side. So you need to know what this graph is. The absolute value of x, what does the absolute value do? So the absolute value is like a function itself. Let's look at some others. So you really need to memorize these graphs. K of x is equal to, and we talked about this one earlier, the square root of x. So the square root of x looks like that. I guess f is overrated, but we tend to use it a lot. Okay, so f of x in this particular function here, we're going to define it as 1 over x, and this graph is looking something like that. And I think on this same xy axis here, we will draw another graph, and this could be any real number here. I'm going to use 3, and this is a constant, so we'll say that it looks like this, right? It's supposed to be a straight line. Okay, and it's passing through the point on the y-axis, 0, 3. So this is a constant. So these graphs you need to seriously remember. You need to know what a constant, the graph of a constant looks like, right? 1 over x, really important. Okay, I can't stress how important this is, that you must memorize these. The square root of x. These are your basic graphs that you're really going to be working with mostly. And what x looks like, right? X squared and x cubed. And from these, it's going to really take you far. And really what we're going to be doing is just moving these graphs around in the xy plane. We may take this line here and move it, right? It may just get moved, and that's called a transformation. Or we may take this parabola and lay it down a little bit. Right, these are known as transformations, and if you just understand the basic graph that's passing through the origin here, and once we move it around and stretch it and move it up and down and squeeze it and all that kind of stuff, if you know what that basic graph looks like, you'll get it. You'll know better what the graph is going to look like, and through that you can make a lot of good observations and save a whole lot of time.